Hello and welcome to PCB Chat. I'm your host, Mike Buetow. Today's podcast is sponsored by PCB Update, the free digital newsletter for the printed circuit industry. Visit the website at pcbupdate.com to subscribe. We recorded this podcast live at Zuken Innovation World. Our apologies for any background noise on the recording. I'm here with Kyle Miller, who has a PhD in artificial intelligence, and he is heading up the routing group at Zuken. Kyle just finished up a presentation on machine learning for computer-aided design. Kyle, when we talk about artificial intelligence and machine learning in board-level CAD, what does this imply?
One of the things I've worked on for many years is, I'm going to use the word traditional tools, such as autorouters and placement tools, and things that basically are helping the designer to do something. What we are trying to do is take away the automated result. So what I mean by that is if you use an automatic tool, the feedback we've had always, and the reason people hate automatic tools, certainly the older generation, they don't like the result because it doesn't look like a human has done it. So what we are trying to do in that space is develop a tool that can emulate a human being, basically, to make decisions in the same way a human being does. And when we've approached problems that we've tried to solve in this, the first question we ask is, how does a designer decide what they're going to do next? How do they make the decision about how they're going to do that? So that's essentially, that's in a very broad nutshell what we're trying to do with the thing. We're trying to emulate a PCB designer.
Given the vast number of constraints, how can machine learning hope to keep up?
Well, actually, I think machine learning can probably keep up better than someone who has to read about it. As long as we can keep up with it at Zuken, then we're okay. We can build whatever is into that is needed into the system as a new thing. We can retrain, we can develop new techniques, and actually keep up with anything that happens in the PCB industry or in the EDA industry by just observing it and saying how can we fit that into our system. And again, there may be issues of retraining internally, but the customer will probably never see that. So we can deal with all that in-house, and then the next thing they see is some new system that can cope with that new technology.
In your presentation, you talked about the generator and the evaluator,
Correct.
with the generator being the machine learning-based technology.
Actually, both of them can be machine learning based, but the point is, if you're trying to do something creative, what you really do want is a separation between the thing that's doing the creating and the thing that's checking how good that is or evaluating it. In more traditional image-based machine learning, there's something called a GAN, which is a generative adversarial network, and what that is effectively is two networks that fight against one another. The job of the discriminator is to decide whether the data it's been given is real or not. So what you do is you use the generator to generate data, and you pass that to discriminator, and the discriminator says, if the discriminator says yes, that looked real, then it has won, and the generator knows it needs to get better at generating data to fool that discriminator. So, and the discriminator has to get better at deciding whether it's real or not. So it also gets past real data, and it has to say yes, that's real, no, that's not. So if you like, that's where the adversarial part of it comes in. They fight against one another and learn off one another and get better at their individual tasks they have to do. And actually, all you have from an external point of view to that system is examples of data. So you just provide in the image case, you just provide images into it, and you just feed them into the system, and they get better and better just from looking at those example images, at generating new images. So it's that kind of basis of model. That's where the kind of the generator and the evaluator idea came from copying that sort of approach.
So at first, could we expect some very different descriptions of what a circuit board should or could look like?
From the system itself, you mean?
Correct.
Yeah. So again, it's not constrained by what we traditionally think of as a good way to lay out a circuit, because the way we're approaching it is to get it to self-learn. It's not taking any preconceptions. So it's not thinking, oh yes, traditionally you lay it out like this, or you put this component there, or you do this. It's not taking any of that into account. Of course, we can build that in because we've got this separate evaluator. The generator, if you like, is a bit more generic in the sense that it is just taking feedback from the evaluator. So anything you want to build in, any information about that system you want to control, you can just build something into the evaluator that will do that. And then that automatically updates the generator, and the cycle repeats until eventually you get what you want out of it. And you can control the evaluator by hardwiring some things in there, or you can again use example data as known good data to get it to tune what the evaluator thinks of as a good result.
Now, specific to Zuken's tools, you're currently using machine learning to focus on routing, correct?
Routing and placement.
And placement,
yes.
Okay. So what do you expect will be the near-term impact on routing?
That's a good question, and actually it's one that we've been trying, the rest of my team are trying to decide while I'm away from the office this week. But one of the modules that's most likely is, you'll have seen in the presentation, but the cluster routing. Mm-hmm. So some sort of multi-signal quick routing tool. So it's that section of it is where we're expecting to see the first results. There's some stuff in the design planning and the placement that's also possible, and maybe even some control of the autorouter, but I suspect that the first point of real results we'll see is in that sort of sub-bus routing type area in an automatic way, generated in an automatic way.
Would you anticipate that if we look down the road, we would get to the point where the machine is actually making recommendations or even really making decisions on better component choices, package styles, taking into account availability and other supply chain issues?
So one of the projects we have just started is escaping from a device, and of course the high pin count devices on any board are typically the critical ones. They determine the number of layers you need, they determine all sorts of features about the design. And one of the other teams is dealing with some sort of web-based interface of part choice and stuff like that. So we're keeping in mind from the feedback. So again, talking about this evaluator, if the evaluator says this part just doesn't work in this environment, it can't fit in, it doesn't do what you need it to do, then that's a point where we can look at another system that looks at that and goes, well, try this alternative part. So at the moment we're just looking at that from a point of view of is the part correct for the PCB? So we're not specifically looking at supply chain issues. However, one of the remits of the team is to look for other areas of our work where that might be useful. So not currently, but it's not ruled out, and certainly the machine learning team in Zuken is looking at other areas, and is there anything else we can look at?
Will that involve necessarily partnerships with other companies as well?
I suspect it will. Again, not investigated yet.
Yeah.
We're just looking at PCBs at the moment, but we have had ideas about how we can tell whether a particular part is suitable in a PCB environment.
Do you fundamentally need a more powerful engine to drive a machine learning based system versus what's currently behind CR8000, for example?
It depends what you're asking about. Do we need one? Zuken, yes. But does the customer need one? Probably not. Mm-hmm. There's the training phase of a machine learning system, and then there's something called the inference phase, which is when it's actually used to give you an answer after the training. The inference phase is typically far, far less compute intensive than the actual training phase. So from our point of view, we've been buying in lots of powerful hardware. At some point we may need to involve some other services, some cloud-based services or something like that to do the actual training. But again, once it's released to customer, no, we're not anticipating. There may be some times where, say, a decent graphics card would help them, but we're not anticipating massive hardware layouts from a customer point of view.
Throughout this development phase, has there been any internal discussion over what the implication is for the actual human who's operating the system and doing the design? Because I would anticipate that with any revolution, there's always pushback.
Yeah.
So how do you overcome that?
So again, putting a kind of a realistic hat on, there'll always be space for some design from a human in there. Even in the models we've come up with, if you what we've done is shifted what's designed. So instead of actually laying out individual traces on a PCB, you might be controlling some other aspect of the design that is then handled automatically. So it's like, shifting the parameters that you're actually designing. And I still think there'll be some human level design over the style and the way the way things are laid out, and I suspect if the final solution will be scalable. So you can say make it completely automatic, or I want some level of control over it. So yes, we've had discussions like that, but we're quite a way away from that end goal of complete automation from effectively schematic to production of the board. So we're not yet at a level where we know that that's definitely going to replace all humans or whatever. But no, so we've had discussions about it, but I think there'll always be some level of design from a human being involved in the process. So.
I think one could argue, just based on the conversations I've had with all the major ECAD vendors, one of the consistent things that they report is frustration that more designers don't use the auto router to greater completion levels,
sure.
Especially in the West.
Yeah.
And so I would expect that, given just the time and resource constraints that every individual designer has, where many of them are engineers wearing multiple hats these days anyway, that anything that helps them automate that process, that place and route process just to start, is probably, they would welcome with open arms.
Yeah, sure. Well, I'm not sure how many people really go into an industry thinking I'm going to be a PCB layout person. Of course, like me, my background is electronics, and I wanted to design circuits. I wasn't, I'm not really that interested in how the PCB is laid out. Of course, if I'm a product engineer, I might want to design a watch or something that is in a particular package. So there's some constraints there. But really, the interesting part is the engineering side of it, not the sort of, for me anyway, the PCB layout part of it. So yes, I think. And certainly in the prototyping space, I've seen other people, want this as well, where they just want to get a schematic. This is my schematic. This is the system I'm trying to design. Give me a prototype board of it. So if you can imagine, even if you don't get something that is suitable for mass production, there's certainly something you can use there from a prototyping point of view. Give a quick turnaround, 24 hours even for designing and producing a board for something I just want to prototype very quickly. So
great. Well, thank you. We've been talking with Kyle Miller of Zuken. Kyle, I'd like to thank you for joining us on PCB Chat.
Thank you.
And good luck with the rest of the show.
Thanks very much.
Great. I want to remind listeners that today's podcast has been sponsored by PCB Update, the free digital newsletter for the printed circuit industry. Visit the website at PCBupdate.com to subscribe. This has been Mike Buetow for PCB Chat. Have a nice day.